Welcome once again to one more video of the topical questions. This video we will discuss the topical questions of the equilibrium constant Kp. One or two questions you may find for Kc also. And before we start with the questions, let me tell you that don't forget downloading the PDF of this worksheet from the description of this video. In that file, you will also see the questions of the equilibrium constant Kc2. So, it will help you out a lot. Let's start with the first question, which says there are first 5 questions MCQs. So, let's discuss those MCQs first and then we will come across the subjective questions also. So, the first MCQ is hydrogen and carbon dioxide gases are mixed at 800 Kelvin. A reversible reaction takes place and the reaction is given here. At equilibrium, the partial pressures of hydrogen and carbon dioxide are both 10 kilopascals. Kp value is 0.2888 at 800 Kelvin. Again, what is the partial pressure of carbon monoxide in the equilibrium mixture? So, to find out the answer, first we need to write the expression for Kp, which says partial pressure of product first, that is H2O, into partial pressure of one more product, that is carbon monoxide, divided by the partial pressures of reactants, that is hydrogen, and partial pressure of carbon dioxide. Now we are supposed to find out the partial pressure of carbon monoxide. So, this is what we have to find out and the other values are given. That is, the value of partial pressure of hydrogen and carbon dioxide is given as 10 kilopascals. Partial pressure of water is not given, but as we can see in the question that both the products are in the ratio of 1:1, so number of moles of both the products will be same. That's the reason that the partial pressure of both the products applied will also be same. So we can say that the value of partial pressure of water and carbon monoxide should be same. So we can rewrite the expression as partial pressure of carbon monoxide to the square, because both the values are same, divide by both the values of partial pressure of hydrogen and carbon dioxide again are same. So we can write as 10 square, that is 10 kilopascal, equal to the value of Kp, that is 0.288. Now if we want to find out the partial pressure of carbon monoxide, it has to be 0.288 into 100 and the root of the whole value to remove the square from here, which gives us the value of 5.37 kilopascals. So our answer is A, that is 5.37 kilopascals. The next question is the equilibrium constant Kc for this reaction is 60 at 450 degrees Celsius. What is the number of moles of hydrogen iodide in equilibrium with 2 moles of hydrogen and 0.3 moles of iodine at 450 degrees Celsius? So we have to find the number of moles of hydrogen iodide at equilibrium. Before that, we need to write the expression for Kc, that is the concentration of hydrogen iodide raised to the square, raised to power 2, divided by the concentration of hydrogen into the concentration of iodine. Now if we substitute the values, we have to find out the moles of hydrogen iodide. So let that be as such, but hydrogen iodide raised to the power 2 divided by substituting the values of hydrogen and iodine as 2 into 0.3 and the value of Kc is 60 from the question. So it gives 60. Now if we want to find out the value of hydrogen iodide concentration, that is the number of moles, we can say that 60 into 2 into 0.3 and the root of the whole value, which is equal to the root of 36, which is again equal to 6. So if our answer is 6, the answer should be C with the value 6 as the moles of hydrogen iodide. Let's go to the next question, third MCQ. Nitrogen dioxide exists in equilibrium with dinitrogen tetroxide, and the equation is given here with the enthalpy value of -57. That is, the reaction is exothermic. Now the question is, which conditions gives the greatest percentage of N2O4 at equilibrium? Looking at the equation, dinitrogen tetroxide has a moles of 1, while nitrogen dioxide has 2 moles. That shows that the product side, dinitrogen tetroxide, has lower number of molecules. So if we want to have a greater percentage of dinitrogen tetroxide with lower molecules, we should have a higher pressure. So our option C and D gets eliminated out. Now if you look at the delta H value, which is exothermic, that shows that the forward reaction to produce dinitrogen tetroxide is an exothermic reaction. So to increase the yield, we should have lower temperature. So this gives us the option of B with the correct answers, that is high pressure and low temperature. The fourth MCQ. The fourth MCQ is, when a sample of hydrogen iodide is warmed to a particular temperature at equilibrium, this is the reaction. At this temperature, it is found that the partial pressures of hydrogen iodide is 28 times the partial pressure of hydrogen. What is the value of Kp? Now, if we know that the partial pressure of hydrogen iodide is 28 times the partial pressure of hydrogen, but as the equation shows that hydrogen and iodine both are at the ratio of 1:1 moles, so partial pressure also applied by both the species should be same. So suppose if it is X, consider the partial pressure applied by hydrogen and iodine as X pascals, then the partial pressure of hydrogen iodide should be 28x. So if we write the expression of Kp, it is the partial pressure of hydrogen multiplied by partial pressure of iodine divided by the partial pressure of hydrogen iodide raised to 2, that is square. Now if you substitute the values, we have x into x, that is x square, divided by 28x to the square. Solving it further, we get x square divided by 28 square, that is 784x square. Now we can cut the x square both from numerator and denominator, which gives us as 1 divided by 784, which is equal to 0.00128. So if this is the value of Kp, that is 1.28 into 10 power minus 3, then our correct option is A. With few MCQs done, now let's solve some subjective questions. The first question is, hydrogen chloride undergoes a reversible reaction with oxygen, and the reaction is given here. The reaction is carried out at 400 degrees Celsius with the catalyst. When 1.6 mole of HCl are mixed in a sealed container with 0.50 moles of oxygen at 400 degrees Celsius, 0.60 moles of chlorine and 0.60 moles of water are formed. The total pressure inside the container is 1.5 into 10 power 5 Pascal. Calculate the amount in moles of HCl and oxygen in the equilibrium mixture. So before we find out the moles of HCl oxygen, we need to write the reaction once again, which we are writing now. So chlorine, 2 chlorine plus water. Now the initial moles of The reactant species are given here 1.60 and 0.500 for oxygen. So let's write that first with 0.500, and the moles of chlorine and water are obviously 0 initially. At equilibrium, the moles, what is given in the question is 0.60 moles for chlorine and water both. So 0.600 and 0.600 moles for chlorine and water both. Now to find out the moles of HCl and oxygen at equilibrium, we need to look at the mole ratio first. So comparing the mole ratio of HCl and chlorine, it is 2:1 because it's 4:2. So it is 2:1. So if 0.60 moles of chlorine is formed, the double should be used up. So we need to subtract 0.60 multiplied by 2 from the initial moles. And for oxygen, we can see that the mole ratio is half of it, that is the 2 moles of chlorine gives 1 mole of oxygen used up. So half of 0.60 is used. So we can say that 0.300 got used up. So this gives us the value of 0.200 for oxygen, and here this value ends up in 1.20. So this gives us, after subtracting 1.60 minus 1.20, we get the value of 0.400. So the moles of HCl and oxygen at equilibrium is 0.40 and 0.20 respectively, which we can write in our blanks here as 0.400 moles and 0.200 moles. Now let me specify here that it is necessary to write the zeros after the decimal, because we need to write the answers with 3 significant figures as it's given in the question also. So we need to maintain the style of writing the answers, and that's why we are writing it as 0.400 and 0.200 moles. Now next look at the sub question. It says calculate the mole fraction of chlorine and hence the partial pressure of chlorine in the equilibrium mixture. And to calculate the mole fraction, you should have the moles of chlorine and the total moles of all the species in the reaction at equilibrium. So if we have a look at the moles of chlorine, it is 0.60, which is given here, and we need to calculate the total moles. So the moles of chlorine is 0.600 and the total moles is 0.400 plus 0.200 plus 0.600 for chlorine and the remaining product. This gives us the total value of 1.800. So mole fraction of chlorine, is equal to 0.600 divided by 1.80, which is equal to 0.333. And to calculate the partial pressure, we should know the total pressure of the system, which is given here as 1.50 into 10 power 5 Pascal. So partial pressure of chlorine, is equal to mole fraction of chlorine into total pressure. So we have 0.333 multiplied by 1.5 into 10 power 5 pascals, and this gives us the value of 5 into 10 power 4 pascals. So the mole fraction of chlorine is 0.333 333 and the partial pressure of chlorine is 5 into 10 power 4 pascals. The next sub question of the same question is, in a separate experiment an equilibrium reaction mixture was found to contain the 4 gases at partial pressures as given here, and the equation is also given. Use this information and the expression to calculate the value of Kp and state the units of Kp. So we need to substitute all the values here. Partial pressure of chlorine is 3.6 into 10 power 4 square into partial pressure of water, that is 3.6 into 10 power 4 again square, divide by partial pressure of HCl, that is 4.8 into 10 power 4 to the power of 4 into the partial pressure of oxygen, that is 3.0 into 10 power 4, which doesn't have any power, and this gives us the value 1.05 into 10 power minus 5. Now if you calculate the units, we have Pascal square into Pascal square divide by Pascal to the power 4 into Pascal. So here Pascal power 4, this and this gets cancelled and we are left with 1 upon Pascal. So the unit is Pascal power minus 1. So our final answer is here with the value of Kp and the unit, which can be written here in the given blank as 1.05 into 10 power minus 5 and the unit as the same. Now the next sub question says that the reaction is repeated without a catalyst. State the effect of this on Kp. Now there is no effect on the value of Kp, and the reason is that there is no effect on the value of Kp because catalyst affects both the forward and backward direction in the same way. It increases the rate in both the directions the same. So the value of Kp does not get affected because the equilibrium mixture doesn't get affected because of catalyst. Let's go ahead with the next question, which says again the dinitrogen tetroxide and nitrogen dioxide exist in equilibrium with each other. The number of moles of dinitrogen tetroxide that dissociates can be represented by N. State in terms of N the amount in moles of NO2 in the equilibrium mixture. Now if we look at the mole ratio of the reaction, it is 1:2. So if N moles have dissociated, then 2N moles must have formed. So the moles of NO2 at equilibrium is 2N. Further, the question says that the number of moles of dinitrogen tetroxide remaining at equilibrium is 0.05 minus N. State in terms of N the total amount in moles of gas in the equilibrium mixture. Now if the number of moles of N2O4 remaining at equilibrium is 0.05 minus N and the moles of NO2 is 2N, then if we add both, we get the value as 0.05 plus N as the total number of moles of gases in the equilibrium mixture as our answer. The next sub question is, state in terms of N the mole fraction of NO2 in the equilibrium mixture. So for mole fraction of NO2, it should be the moles of NO2 divided by the total moles. So now the moles of NO2 is 2N. So moles of NO2 2N divided by total moles, that is 0.05 plus N, which we have calculated here. And so the mole fraction of NO2 is given in the expression in terms of N. The next sub question says that use your answer to 1 and 3 to calculate the amount in moles of each gas in equilibrium mixture, give your answer to 3 significant figures. Now it is also given that in equilibrium mixture the mole fraction of NO2 is 0.400. So now if we have moles of NO2 as 2N, then let's substitute the values here as 2N upon 0.05 plus N equal to 0.400, which is given here in the question. So if we find out the value of N, we get 0.0125. So NO2 moles is equal to 2 into 0.0125, which gives us the value of 0.0250. And as we have seen in the question earlier that the moles of N2O5 is equal to 0.05 minus N. So if we substitute the value of N here, it is 0.0125, we are left with 0.0375 moles of N2O4, that is dinitrogen tetroxide. Now the next sub question is, write the expressions of equilibrium constant Kp for this reaction. Now looking at the reaction, the product is NO2 and the dinitrogen tetroxide is the reactant. So if we substitute that here, partial pressure of NO2 square divided by the partial pressure of dinitrogen tetroxide, that is N2O4. Now looking at the next sub question, it says use the total pressure mixture as 1.68 into 10 power 5 Pascal to calculate the value of equilibrium constant Kp, give its units. Now to calculate the Kp, we need to have the partial pressure of both NO2 and dinitrogen tetroxide also. So we need to calculate that first, which is equal to 0.0250 divided by the total moles, that which is 0.05 plus N, which was 0.0125. So this will give us the value as 0.4 into the total pressure, that is 1.68 into 10 power 5 Pascal, and the partial pressure of N2O4 is equal to 0.0375, again divided by the total moles, that is 0.0125. This gives us the value of 0.6 multiplied by total pressure of 1.68 into 10 power 5 Pascal. Now substituting this as 0.4 into 1.68 into 10 power 5 should be in the square, divide by 0.6 into 1.68 into 10 power 5, and this gives us 44,800 Pascals. The unit is Pascals because if we have Pascal square divide by Pascal, it gets cut off and we are left with Pascals. So our value is 44,800 Pascals.